Did you know that China has long dominated the world of battery technology, leaving the US and Europe playing catch-up? Most EVs in the US still rely on batteries from China. That's an undeniable fact. But hold on for a second because something is happening. A US company has just launched a battery that is considered a game changer in the industry. It's not solid state, nor is it traditional lithium, but something that goes beyond both, with advantages that have left experts stunned. This type of battery is more durable, performs flawlessly in extreme cold, charges lightning fast, and delivers an unprecedented energy density of 660 watt-hours per kilogram. What does that mean? An EV could travel up to 1,000 miles on a single charge, and Tesla might soon have access to it since it's being manufactured in the US. Not a rumor, but Sandy Munro, an expert in batteries and EV engineering, a legend in the automotive industry, witnessed it with his own eyes at the factory and praised it endlessly. Even right after Sandy's video, the company was honored with a global award for their breakthrough technology. Can the US surpass China in the battery race? We think not yet, but in the future we believe it is possible. So what is special about this battery technology? Will it soon be available in Tesla EVs? We will reveal it right now. The battery technology we're talking about today is the semi-solid lithium-ion battery developed by a company called 24M. 24M stands for 24 Molecular, a battery technology company based in Cambridge, Massachusetts, US. They're well known for pioneering the unique semi-solid lithium-ion battery technology, designed to address major challenges in the battery industry such as high costs, safety, energy density, and recyclability. At the heart of 24M's innovations is a commitment to lean manufacturing principles. Traditional lithium-ion cells rely on complex winding processes and precise alignment of anode, cathode, and separator layers, processes prone to failure modes like dendrites and internal shorts if tolerances drift. 24M simplifies this with a proprietary semi-solid manufacturing method called Live Forever. Instead of using binders and layering electrode components, 24M mixes electrolyte with active material into a viscous slurry and casts it directly onto foil. This reduces process steps by 50%, slashes capital costs, lowers energy consumption, and allows for thicker electrodes. The result? Higher energy density, improved safety, and a more sustainable production process. The truth is that actual test results have shown energy densities up to 660 watt-hours per kilogram, surpassing the 400 watt-hours per kilogram threshold, critical for sectors like aerospace, high-performance EVs, and eVTOLs. Lighter batteries with higher energy density directly translate into longer range, better efficiency, and lower system costs. You know about solid-state batteries, right? We think you've probably heard of them at least once. To put it simply, this is a type of battery that uses solid electrolyte instead of the liquid electrolyte found in traditional lithium-ion batteries. The electrolyte is the material in the middle of a battery cell that allows ions to move back and forth between the anode and cathode during charging and discharging. To make it even easier to understand, if a lithium-ion battery is like a sandwich with just sauce in the middle, then a solid-state battery is like a sandwich with meat filling inside. Now, 24M's battery isn't a solid-state battery, but it can charge 200 miles of range in just 4 minutes. Yeah, that fast. And what makes this battery special is that it doesn't rely on high-cost megawatt charging stations. 24M says that you don't need a 1 megawatt charger, which means this charging speed is even better than BYD's because it works effectively on standard 400 volts or 800 volts chargers, making better use of the current. An energy density of 660 watt-hours per kilogram is more than enough to achieve over 1,000 miles of range. In fact, in China, CATL has already developed a battery with 500 watt-hours per kilogram, and they've confirmed that 1,000 miles is easily achievable. That 1,000-mile figure carries huge significance for electric vehicles. It goes far beyond the average daily need, allowing drivers to travel across multiple states without needing to stop and recharge. For comparison, a typical gasoline car has a range of about 400 to 600 miles per tank. So hitting 1,000 miles not only puts EVs on par, it makes them superior in terms of convenience. And the fact that it can charge 200 miles in just 4 minutes, that's a game changer. It removes one of the biggest barriers to EV adoption, charging time, which has long made people hesitate about switching to electric. This battery technology truly made us say, why haven't we seen this sooner? No surprise, it just won the award for Best Technology of the Year. While the solid electrolyte in solid-state batteries is seen as a revolutionary replacement for liquid electrolytes enabling higher energy density, it comes at a cost. Solid-state batteries are still very expensive, and battery degradation remains a major challenge. That's why 24M has taken a different approach, using a new type of electrolyte called Eternalite, which enables faster charging and significantly improves performance in cold conditions. Yeah, 24 million can't reveal too much about this eternal electrolyte, since it's a proprietary technology and exposing too many details could lead to it being stolen at any moment. However, according to publicly available reports, this proprietary solvent dramatically improves low-temperature performance. In testing at -40 degrees Celsius, 24 million cells retained full power and energy transfer, outperforming conventional electrolytes, which freeze or lose conductivity at those temperatures. As we all know, when temperatures drop to -20 degrees Celsius, traditional lithium batteries perform very poorly. Standard batteries can lose 25 to 30% of their capacity at 0 degrees Celsius, especially lithium iron phosphate types. Eternalite, on the other hand, retains nearly full capacity at 0 degrees Celsius and maintains over 80% even at -40 degrees Celsius, something that's almost unheard of. Eternalite shows virtually no weaknesses. This electrolyte has 3 times the ionic conductivity of standard materials, allowing ions to move faster between the anode and cathode, resulting in charging speeds up to 4 times faster. For EV markets in cold climates and military applications where extreme temperature resilience is vital, this is a huge advantage. The CEO of 24M said, "Eternalite solves some of the biggest challenges facing lithium batteries today." But here's the key point we haven't mentioned yet. This electrolyte can be used not just in one type of battery, but across a wide range of lithium-based batteries. Whether it's Tesla's 4680 cells, or batteries using silicon or graphite, as long as it's lithium-based, you can use Eternalite to instantly boost energy density. According to 24 million, integrating this electrolyte into existing manufacturing lines isn't difficult, and when combined with the company's Impervio separator, it offers unmatched safety and battery longevity. Speaking of the Impervio separator, it's the very product that just won Fast Company's 2025 World-Changing Ideas Award. Here's an easy way to understand it. 24M's Impervio separator is a breakthrough in battery fire safety, designed to address key risks like overcharging and internal shorts, the main causes of thermal runaway that leads to fires and costly recalls. By actively suppressing dendrites and enabling early fault detection, Impervio can prevent thermal incidents before they start. It enables next-generation lithium-ion and lithium-metal batteries to deliver enhanced performance and safety without sacrificing manufacturability across EVs, energy storage systems, consumer electronics, aviation, e-bikes, and more. Impervio separators add an embedded conductive layer between insulating layers. This actively suppresses dendrite growth and acts like a circuit breaker at the cell level. The separator can detect early signs of internal shorts and communicate with the battery management system to isolate and safely discharge compromised cells. The batteries, which will power our vehicles in 2030, are in the laboratories of today. We have no idea who will win the race to make those next-generation batteries, but if you said 24 million, we wouldn't be surprised. The company is loaded with world-class talent from top to bottom. Cell-to-pack is the new thing today, but electrode-to-pack is a more efficient way of making batteries by at least an order of magnitude. 24M's electrode-to-pack concept represents another leap in lean design. By creating carpet cells, large area sealed electrode assemblies laminated with polymer and separator layers, the company eliminates the need for hundreds or thousands of individual cylindrical or pouch cells in a pack. Picture replacing 300 small cylindrical cells in an EV with just 6 large-format carpet cells. This minimizes packaging overhead, reduces wiring and bus bars, and improves both volumetric efficiency and energy density. Fewer parts also mean fewer potential failure points and simpler pack integration. Manufacturing these carpet cells is already semi-automated and easily scalable. The simplified architecture offers clear cost benefits, with estimated 30% lower costs per kilowatt-hour versus conventional designs, an industry game-changer for reaching targets below $100 per kilowatt-hour. With the $7,500 federal EV tax credit, now requiring that EVs use batteries free from Chinese-sourced materials, Tesla's feeling the heat to find alternative battery tech. It's the only way to stay competitive and keep cars, like the Model Y, Model 3, and Cybertruck eligible for those incentives. Sure, there's a temporary exception until 2027 that still allows graphite from China, but Elon Musk isn't waiting around. He's already pushing hard on domestic solutions like Tesla's own 4680 battery cells. So if 24M's battery tech really starts gaining traction anytime soon, you can bet Musk will have his eye on it. Battery recycling is an industry bottleneck, but 24M's design offers a lean path forward. The sealed electrode architecture, free of binders, enables mechanical separation of anode and cathode streams. There's no need for harsh pyrometallurgical or hydrometallurgical processing. As far as we know, Li-Forever technology allows up to 98% of battery materials to be recycled without creating black mass, making it environmentally friendly. This not only simplifies recycling and reduces environmental impact, but also supports a true closed-loop battery ecosystem, a critical step as EV adoption accelerates. As of mid-2025, 24 Million has built out a 140,000 square foot facility near Cambridge, Massachusetts, and is scaling toward 200 megawatt hours per year production capacity. The company is actively partnering with automotive OEMs and defense primes to bring these next-gen cells to market. According to leadership, production ramp-up could begin by the end of this year, a timeline accelerated by investor and partner interest. 24M Technologies represents a rare leapfrog in battery design, one that addresses energy density, safety, manufacturability, and recyclability all at once. For EV engineers, this platform offers new tools to extend range, lower pack costs, and simplify assembly. For investors and OEMs, it marks a strategic opportunity to outpace rivals, particularly in the race to outperform Chinese battery dominance. And for enthusiasts, it promises batteries that deliver consistent performance in the harshest real-world conditions. Switching to other news about Tesla Robotaxi. As we all know, Tesla's self-driving taxis have officially launched operations in Austin, Texas. While the service is currently limited to a small group of influencers and early testers, it's expected to roll out to the general public on a much larger scale by the end of this year and into next year. The introductory fare is just $4.20 per ride. Tesla's Robotaxi service kicked off with a modest fleet of around a dozen Tesla Model Y vehicles, operating within a 15 to 20 square mile area in South Austin. Users can book a ride from 6 a.m. to midnight using the Tesla app on their smartphones, following a process similar to other ride-hailing apps like Uber or Lyft. The fleet is expected to expand significantly as the service enters full-scale deployment. Unlike traditional ride services, Tesla's Robotaxi offers a unique experience. Passengers are greeted with onboard music and preloaded video entertainment, as well as the ability to adjust the cabin temperature to their personal preference. Notably, during the testing phase, there are no drivers, only a Tesla safety operator sitting in the front seat to ensure safety. However, their role appears mostly observational, with minimal interaction with passengers. If an emergency stop is needed, passengers can contact a remote Tesla operator, while the in-vehicle supervisor remains passive. In its early days of operation, Tesla's Robotaxi has demonstrated impressive performance. It has successfully navigated heavy traffic, avoided wildlife, and maneuvered through tight parking lots in Texas. That said, a few noteworthy behaviors have been observed. For instance, the vehicles have occasionally exceeded the speed limit by a few miles per hour to keep up with traffic flow. Technically a violation, though not dangerous. In other cases, the car briefly drifted into the wrong lane, although it fortunately escaped police notice. These Model Y vehicles, use a customized version of Tesla's full self-driving software, but they are essentially standard cars, marked only with robo-taxi logos on the sides and rear. Their driving behavior closely mimics that of a human, taking advantage of gaps in traffic to pass or making slight natural steering corrections. This demonstrates how far Tesla's full self-driving technology has progressed, offering a ride experience that feels surprisingly human-like. One major difference compared to services like Uber is that passengers don't need to pay attention to the road. Thanks to full self-driving capabilities, they can freely check emails, watch videos, or play games on the in-car entertainment system. In fact, the upcoming Cybercab is what Tesla considers a real robo-taxi, a two-seater with no steering wheel, no pedals, extra storage space, and even an onboard self-cleaning robot system. It's expected to be priced under $30,000 with mass production starting next year. The Cybercab is poised to redefine the future of robo-taxis. In the meantime, the Model Y is leading the charge. Tesla has stated that any vehicle equipped with full self-driving could eventually join the robo-taxi network, unlocking massive potential for the millions of Teslas already on the road worldwide. Tesla's self-driving technology is powered by a neural network trained on millions of hours of driving data collected from Tesla users. Instead of hard-coding responses to every possible scenario, the system allows the car to think and react like a human, using 9 continuous camera feeds. This vision-only approach sets Tesla apart from competitors like Waymo, which relies on radar and LiDAR sensors to gather data. Although both systems have made significant advancements, Waymo currently leads in scale, with around 1,500 vehicles operating across multiple cities, including Austin. Waymo plans to double that number by the end of 2026. However, each Waymo vehicle costs roughly $150,000 to produce, compared to under $40,000 for a Model Y, giving Tesla a major economic advantage in the robo-taxi race. Tesla's robo-taxi service isn't just a technological leap, it's also a highly promising business model. With millions of vehicles already sold, Tesla has the potential to rapidly scale up its robo-taxi network without needing to invest heavily in manufacturing new cars. Furthermore, the relatively low cost of the Model Y compared to rivals like Waymo gives Tesla a significant price advantage. However, challenges remain. Minor issues like speeding or drifting out of a lane, even slightly, could pose legal risks and undermine public trust. Tesla also needs to ensure its self-driving system can handle every complex situation without human intervention, an ambitious goal that even Waymo has yet to fully achieve. As a final takeaway in today's episode, what's particularly exciting for supporters of the EV revolution and the transition to all battery electric vehicles is the potential of new battery technology that enables long-range travel with minimal charging time. The battery tech from 24 million might be exactly what the doctor ordered to make that revolution truly succeed. At this stage, 24M's batteries still need to be tested by automakers under real-world conditions to confirm their performance, including in both hot and cold climates. But with this announcement, the company may have just lifted the curtain on the next phase of EV adoption. Solving the range anxiety issue would be a massive boost for the electric car and truck industry. The future of electric transportation is no longer just approaching. It may already be here, thanks to 24M. How do you think 24M's semi-solid battery technology, with its 1,000-mile range and 4-minute charging capability, will transform the EV industry? And could it help the US keep up with China in the battery technology race?